We want to finish up section P3 starting on page 31 with parallel and perpendicular lines. Remember that parallel lines always have the same slope. Perpendicular lines have slopes that are opposite reciprocals of each other. So, for instance, if you have a positive 2, the perpendicular slope is going to have to be the opposite, negative, and it's going to have to be the reciprocal. So flip 2 over 1 to get 1/2. So if your slope was a negative 3/4, what would the perpendicular slope be? Yes, positive 4/3. All right, so example 6, they ask us to create the equation of the line that goes through the point 2, -1 and is parallel to 2x minus 3y is equal to 5. So I have a point. What do I need? Right, a slope. So yesterday we learned 2 different ways that we could find that slope. We could create an equation in slope-intercept form by solving our equation for y. So we would subtract the 2x to the other side and divide by the -3. And then I want to put that in mx plus b form. So I'm going to turn that around so it's y equals mx plus b. So there's our slope of 2/3 right there. The other way we could get it is by the definition that slope is the opposite of a over b. So if my a value was 2 and my b value was -3, then I could say the opposite of a, or a negative a, so a was 2, over b, which was -3. So that would give me a positive 2/3 for my slope. Okay, whichever of those 2 methods you want to use, doesn't matter to me, but now we have a point and a slope, and now we're right back to what we were doing yesterday. So if I have a point and a slope, I can use point-slope form. So let's fill in what we know. We could take x1, y1, and m and put them in the equation. So y1 was -1, m was 2/3, and x1 was 2. So let's simplify. Minus a negative is plus, and distributing the 2/3 would give me 2/3 x, and then minus 4/3. They want our equation in standard form, so let's move it all over to the left-hand side. So subtract the 2/3 x over and add the 4/3 over. 1 and 4/3 would give me 7/3. Remember, in standard form, you're not allowed to have any fractions. So I'm going to multiply by the least common denominator of 3 to clear out all those fractions. Now, there is nothing wrong with this equation right here, but that is not what it would have in the back of the book. The book does not like, and a lot of textbooks do not like your leading coefficient to be negative, so they would multiply this whole thing through by a -1, so then that would give you a positive 2x, -3y, -7, like you see here. These are equivalent equations. It does not matter which way you write that. It would graph the same way. It would have all the same information. All right, look at example 7. The only thing that we change about example 7 is that we change parallel to perpendicular. So we still have the same equation. The slope of that equation we had found to be 2/3. So what is your perpendicular slope going to be? Yes, -3/2. So yesterday I showed you 2 different ways that you could do this. You could use slope-intercept form, or you could use the opposite of a over b, and I asked you to play around with them last night. You do not need to write both of these down. Whichever method you decided last night that you liked better, go with that one. So if you like point-slope form better, we're going to do exactly what we did a second ago. We're going to plug -1 in for y. We're going to plug positive 2 in for x. And that perpendicular slope that you just told me, -3/2 in for m. So to simplify, minus a negative again is plus. Again, distribute that -3/2. Move it all over to the left-hand side and get rid of the fraction. So there would be our standard form. If instead you liked that opposite of a over b method from yesterday, let me remind you of how we do that. If our perpendicular slope is -3/2, then we could match this up and say the negative matches up with the negative, a matches up with 3, and b matches up with 2. So come down here and put 3 in the place of a, put 2 in the place of b, and look how close we are to our final answer just in our first step. So we've used our slope, we haven't used our point yet. So let's plug in that point of 2, -1. So I'll put 2 in for x, and I'll put -1 in for y. and then I can solve for my only unknown, which is c. So 6 minus 2 would give me 4. If 4 plus c is equal to 0, then c would be negative 4. So let's bring that up and put it in the place of c, and there's our equation. And you'll notice I get the exact same equation either way. It does not matter to me which of those two methods you use, whichever you prefer. Now, what if our slope for this problem had been a positive 1/2? Instead of it being negative, what if it was positive? I don't have a negative to cancel out with the negative in my formula. So what I could do is I can either write negative a over b as a negative a over a positive b, or I can write it as a positive a over a negative b. It does not make a difference, whichever you like better. So if the definition for slope is given and 1/2 is my slope, I could match that up and I could say, okay, a is going to have to be equal to 1 and negative b is going to have to be equal to 2. So if negative b is equal to 2, divide both sides of that by negative 1, b would be equal to a negative 2. So as we've seen a couple of times in examples already, if you have a negative slope, then it lines up really easily in terms of I have a negative 3 over 2, I have a negative a over b, so the a is just 3 and the b is just 2. If I have a positive slope, all I have to do is say, okay, 1 is equal to a and 2 is equal to negative b. So in essence, one of your values will end up being positive and one of your values will end up being negative. It doesn't matter which way you choose, as we talked about up here, but I'm usually going to let a be positive and b be negative because of the idea we mentioned that the book always likes the leading coefficient to be positive. So since I have my choice, I'll go that way. All right. Example 8, they give me two equations and they ask me to tell, are they parallel, perpendicular, or neither? So what do I need to be able to determine that? Yes, the slope. So let's look at the first one. What's the slope of our first one? Positive 1. And what's the slope of our second one? Negative 1. Right. So are they parallel? No. Why? Right. They would have to be the same. Are they perpendicular? Okay. Why? Yes, they're opposite reciprocals. This one's positive, this one's negative, so they're opposites, and if you find the reciprocal of 1, it is 1. So yes, they are perpendicular. Okay, so here is your homework for tonight on 33 through 36. We're doing 21, 23, 65, and for 65, put that in general form, or standard form, whatever you call it. 89, challenge 79. And on 21 and 23, you do not need to graph those.